start talking. So yesterday, and over the past couple days, we have seen some really cool relationships. And one of the coolest ones that we saw deals with relating circumference to diameter. Excuse me. When we set up the ratio of circumference to diameter, and we do the division, we will always get the value of pi. Now we know pi is actually a big, long number that goes on forever, or at least as far as we've been able to take it so far. But we approximate it, so we use squiggly equals. We approximate it with 3.14. Please make sure plan book you have your homework written down. And we have these two formulas, actually three formulas really, that we've used over the past couple days that you should have in your toolbox now to be able to help us solve problems. So today, we're going to take that and extend it a bit further and actually relate our circumference, or the distance around, sorry, I guess it would help if this was turned on, the distance around the circle to the space inside of it. So let's draw a couple different rectangles. Who can give me some dimensions of a rectangle that we could put on our grid here? Abby?
5 and 2.
5 and 2. So I'm actually going to do 2 and 5.
5.
So if I do 1, 2, 1, 2, 3, 4, 5, that's 4, 5. So what's my perimeter and what's my area is what we want to answer. Well, if I have 5 on top and 5 on bottom, 2 on the left, 2 on the right, Abby, what's my perimeter there?
So you do 10 plus 4.
Yeah, we do 10 plus 4 and we get
14.
14.
Then the area
Is really how many squares are inside of it,
which is 10.
which is 10. So here my area is smaller numerically than my perimeter. And we would label those, I just don't really have space inside of there. Give me different dimensions to make a different rectangle. Okay? 6 and 3, sure. So I'm going to do, how much do I have? 1, 2, 3. I'm going to overlap a little bit, actually. I'm going to go 3 wide, 6 tall. So if I do a 6 by 3, well, again, I've got 6, 3, 6, 3 all the way around, so I really have 9 doubled. So my perimeter would be 18. And then my area, 3 times 6. Interesting. Here, my area was smaller. Here, they're both the same. Let's try a really long one. Let's do a 1 by, however tall this is. 1 by 7. Actually, sorry, I lied. Let's do a 4 by 7. I want to show you this last little bit of the example to show you all 3 situations. So again, I'm overlapping a little bit. So if it's 4 by 7, I know that the length plus the width, 4 plus 7, will give me 11, and then I can double that to get my perimeter of 22. We then want to calculate the area, so we would do 4 times 7, and we get 28. So in my blue, my area was smaller. In my red, my area is the same as my perimeter. And in my green, my area is bigger than my perimeter. So do you think we could make a rule involving rectangles that directly relates area to perimeter? Say yeah or nah? If here area is smaller, then area is same, and then area is bigger, is this staying consistent? So we don't see a consistent relationship. I don't think that we could make a rule. Because this relationship is not staying the same. It's not like as my perimeter gets bigger, my area gets bigger. Well, my perimeter got bigger, and then my area was the same as my perimeter. I could also actually make my perimeter stay the same, and I could change my area. Because if instead of doing a 2x7, what if I did, the perimeter was 14, so if I cut that in half. What if I did 6x1? Really long rectangle, and that's probably not drawn, right? You don't have to draw this. But the perimeter there would still be 14. So my perimeter would still be 14. But if this was 6x1, what would my area be? 6. So, same perimeter, completely different area. Now let's look at some circles. Right in the top corner. So you have a question?
Yeah. So isn't it the perimeter and area were the same for the right one? Isn't that because you used two even numbers?
Not
Or
necessarily.
is it because you used half of the other number?
I don't know that we can actually make a rule like that. So I'm going to put that on the back
Oh, no,
burner.
it wasn't a rule. It was just
I know, but you're asking it like we could make a rule. So when you first asked, is it because we used even numbers? If I say yes, you're going to think if I use both even numbers, that happens. So we could come back to that, but we would need to do more investigation. I'm going to color code this so I can just write the values off to the side. So I'm just going to start in black right in the top corner, put a center dot in 1, down 1. So we're going to make a circle that has a radius of 1. Now remember, our circle area formula is pi times radius squared, where its perimeter formula is pi times 2 times the radius. If we just want to use the radius again, we're going to keep these in terms of pi. So for my black circle here, what would the area be? If I have a radius of 1, I square that and I multiply by pi. Abby?
Wouldn't it be pi times 1?
So it's just pi, right?
Because if it's 1 squared, 1 times 1 is still 1.
Yeah. So my area for my black one here is pi, and my perimeter, well, 2 times 1 times pi is actually 2 pi. Let's make another circle. But now, let's do 2 by 2. So I'm going to come down, we'll go in the corner still. So now we have a radius of 2. So that's 2, and that's 2, and that's 2, since they're all radii. My area, when I do 2 squared times pi, gives me, Andrew, what'd you get for that? 2 squared? What's 2 times 2?
Well, that's 4.
So, leave pi as pi. You don't need your calculator. It's just 4 pi. If we're going to not replace pi with 3.14, then my perimeter here, 2 times the radius of 2 times pi, well, 2 times 2 again, you get 4 pi.
Wow.
So the area was less. Now the area is the same. Interesting. Let's try a 3 radius. So you're going to start to overlap here. So here my radius is 3. My area, what's 3 squared? Casey here. Lily, what's 3 squared? 3 times 3? 9. So you get 9 pi. Then my perimeter, I double my radius, multiply it by pi. I get 6 pi. So my perimeter was more. Now my perimeter is less. Interesting. So let's keep these in our brain as we start to investigate if there's a relationship that we can find between the circumference and the area. And this really we would call circumference, but if we started first talking about perimeter over here, your circumference is your perimeter, so we can call it the perimeter or the circumference. Why do we say circumference instead of perimeter? Because it's around, right? We want to use that circum root for around. This is real. Yeah. So this coin weighs 220 pounds, approximately. It has a circumference of 61.9 inches. What is the area to the nearest square inch? Do we care about the weight if we're looking for area and we know circumference? Distractor. It's a distractor. So, first thing we need to use is that my circumference is 61.9. So we want to set up a circumference formula. So circumference equals 2 times pi times the radius. Or we could just use pi d. So actually, let's use pi d. I know. So I'm just setting this up because then we can also say equals. Now, like you just said, Justin, we know it's 61.9. Now, the reason I set it up like this is so we can use some algebra to find out more about my circle. So, Flynn, when you look at, now we can really ignore the c equals because we don't need it. So when we look right here, we're trying to figure out what can I do. So what would we want to figure out there? What don't we know? Do we know what pi is? Yeah, because it's a number. We know it. Do we know the circumference? Do we know diameter? No. How could we get diameter by itself here?
We could divide 61.9 by pi.
Yeah, if we want to get rid of the pi, we're going to divide by the pi. So when you type this in, use 3.14, please. So our diameter is going to be that 61.9 divided by 3.14, and it comes out, Izzy? 19.71. Yeah, so we can use squiggly equals because we're approximating. I will not take off and use regular equals. But now we need area. Ah, we have diameter. Radius will be half of that. So when we half this, we get 9.856. We'll round at the end. So this is going to be pi times radius squared, which when I replace 3.14 times my 9.856 squared. If you're typing this in your calculator, you definitely want to make sure that you put your square here inside your parentheses. So guys, if you take a second to think about this, this coin is 20 inches across. That coin is this wide. It's a gold coin. Now, this is in Canada. It's the biggest coin ever minted. At least back then, it was the largest coin ever minted. We've got giant reserves of gold. They're locked away in a mountain. Canada decided, hey, we'll take some of our gold and melt it into a sweet coin. Like, it was just like one of those things. They just decided to do it. There's really no reason, but they probably just wanted a world record so they could, like, have a record.
How much is it worth?
I forget. You can look it up. I forget what it's, but it's like solid gold. So its worth is probably its weight in gold. So I don't know if they actually like gave it a current. They did. They printed it worth $1 million. So it says on here $1 million. I forget. 07? I forget when they made it. But this was a real thing. Like they made a real coin this big. What's your area come out to be, Izzy?
305.
Is that rounded to the nearest inch already? Okay. Do we have verification? Our area was 305 inches squared. Perfect. So try this on your own. We give you a little bit smaller values to work with. Try the got. We got to use the same exact process because we're given the circumference. I'll give you a couple minutes. Check with your neighbors once you get it figured out. Make sure you write down your work. Write down the process. I'm going to leave my process on the smartboard. So if you're trying to look up here on the smartboard, you're able to. I am missing a big fat pink highlighter. So if you guys see one around school, I would love if it gets brought back.
Is it short?
Is it what?
Is it short?
No, it's one of these. The office one. There's just 4 of each because I bought 2 boxes. What if I walked in wearing a famous flower? What would you guys? By the way, if you guys are doing homework or anything, I have this circle reference poster up here, but once it's not on the chalkboard, I'll put it up on the wall. In case I haven't pointed this out, all your area formulas for our general 2-dimensional shapes that we work with are up here on this poster. So if you're working on homework or whatever and you forget stuff, this is a good place to work on your math work. So if you're in extensions and you're like, hey, can I go over to Hudson's room to work on math? Like, all the different math rules are up on the walls. So if you want to come over here, I invite you. Please come hang out with us. Yeah, which you can still come in here. It's just a little bit distracting. Like, you could still come work in here. You just might be distracted because we're doing cool math problems. Any volunteers? So like come up and show it. You want to show your process?
I think this is it.
You want me to spot check it real fast?
Yeah.
Wait, what is that? You 7. Oh, don't round till the end.
Oh, okay.
So, when you did this, well, snap. Yeah, you can round that off to 7.
Okay.
Never mind. Yeah, show that.
Was that good?
Yeah, just make sure that you show the division on both sides.
Alright.
By the way, while Justin takes a second to write his work up there, I was helping my wife with some statistics last night. We were getting really frustrated because we seemed like we were stuck in an infinite loop of the wrong answer. Yeah, your math teacher can get some wrong answers sometimes. So I realized, like, okay, take a breath. Figure out why we might, like, our process that we were doing was right. So why were we getting the wrong answer? Because we had the answer key. So finally, I start chuckling. And if you've ever gotten an answer wrong a lot of times and somebody starts laughing, you can imagine my wife looked at me with very angry eyes. And I said, so Chelsea, what's 18 plus 22? And she had written down on her paper 30 was the number that we were working with the whole time. She forgot to carry the 1. And we were working with a wrong number. So all the complicated math that we had done, we did it right, but with the wrong number. So if you get frustrated and you're like stuck getting wrong answers, but you think your process is right, back yourself up to saying, what basic math might I have goofed up? Because here we are, 2 college-educated people, and we did not catch a simple addition mistake. Because she hadn't used the calculator, she was just working fast. It's like, what? Yeah. So one simple mistake can shoot you in the foot. All right, Justin, you want to explain your process to us?
Yeah. So 22 is the circumference around. That equals C. Sorry, my writing is terrible. So the diameter equation, circumference equals pi times d, and we got the circumference, so we're using pi as 3.14. Divide 22 by pi, that gets us 7.
And we got like 7.00 something. Which, so when I looked at that, I was like, oh, don't round yet. But if there's 2 zeros after the decimal, go ahead and round that, even though there were decimal values. So then what would you do with that 7? Because the problem actually wants you to find the approximate area.
And so we're doing, well, we have to find a radius for area. So we'd have to divide by 2 since there's 2 radius and
Love it. Keep talking. I'm going to write what you're saying. That would give us 3.5. So then what would we do?
Then area equals pi times radius squared.
So then we use our formula. Now I'm on my tables. And because Justin's up here, did you calculate that yet?
Not yet.
So anyone, Izzy, with our calculation?
Yeah, area is about
38.9. What is our label here? Centimeters. So centimeters squared. Any questions, comments, or concerns for Justin?
Right smaller.
Very good process, but yeah, just work on that handwriting. So, and it's weird writing on the board versus writing on your paper. But as you guys get up in your mathematical career and the work becomes more important, you want to make sure that your teacher can actually read it, because when it's points, the more work they can actually read, the more points they're going to give you. So if you get a problem wrong, you can still get partial points if they can read your work. So of course we don't grade with points, but realize that as you get further up, you want your math teacher to be able to read the math that you're doing. And because I teach middle school, I'm decent at deciphering that. But so let's look at this relationship of area to circumference. So one thing with when we started up top was we started with small circles. So we now start with slightly bigger circles. We start with a radius of 4. And they give us the area of the circumference, and then they divide the area compared to the circumference. And they get 2. No pi's, no anything, they just got 2. If we think about the area for a circumference of 6, Xavier, all we got to do since we're working in pi is square the radius. So what's our 6 squared? 6 times 6?
36.
Yeah, so we get 36 pi. Our circumference, since again we're working in pi, instead of squaring, we just double. So what's our circumference? If we double the 6.
Oh, double 6? 12.
Yeah, you're trying too hard. 12, and then we just put the pi on the end. This is why working in pi, like leaving pi as pi, is really nice. Because then the math is super easy. Now, set up your ratio. 36 pi over 12 pi. Now the pi divided by pi, they cancel. And what's 36 divided by 12? 3. If I do, fill out the rest of your table actually. Take a second. You guys got this. Fill out the rest of your table. Do not look up here if you can avoid it, because I'm going to go ahead and write the values. Anytime you see values that are the same on top and bottom, just ignore them. They cancel each other out. So you can put the slash through them if you want, or you can just realize a number divided by itself becomes 1. Multiplication or division with 1 does nothing. So it cancels out. I hate when people say it disappears. Well, okay, it becomes 1. It doesn't really disappear. We just don't need to say 1 of something. Brandon, when you look at this ratio for the radius of 8, and you really do the math of 64 divided by 16, what'd you get?
I got 4.
When Grace, when we look at the next one, what's my ratio reduced to? We look at the 100 compared to the 20. Ooh, close. 5. That was supposed to be green. You just had this here in the wrong place. Look at this for a second. Can anyone figure out a rule for any circle? So down at the bottom, for any circle, area divided by circumference Julia? Yeah, it's half of the radius. Or your radius divided by 2. So what we can do with that, actually, if we set up over here that area divided by circumference equals radius divided by 2. If I cross multiply, I get that 2 times the area actually equals the radius times the circumference. And I can build a bunch of different formulas from there. You don't have to use these, but this is just really cool stuff that the circle work can do for us. If I want to get radius by itself, radius will be 2 times the area divided by circumference. If I wanted to get circumference by itself, circumference will be 2 times the area divided by radius. If I wanted to get area by itself, area would be the radius times circumference divided by 2. I can build all of these formulas off of this initial result from our cross multiplication. And that's really kind of cool. Because if they give me 1 or 2 values of the circle, I could work all these different formulas and really quickly compute the other ones. Any questions on how I got these formulas? All I did was divisions. Either I divided by circumference, or I divided by radius on both sides, or I divided by 2 on both sides. So let's go to the back. So, actually, before we flip to the back, one last thing to think about. If I know my circumference and my radius, so we see the circle, we know the radius, first thing we compute is circumference. How do I go from circumference to the area? How do I, if I know the circumference, how could I compute the area? Like, how could I get it? Abby, what do I multiply by?
Don't you multiply by the radius?
Ooh, half the radius. So that multiplication will be half the radius. So that's what we're going to use to be nice and save me some work. Because I don't like doing more work than I want to. Like, I want to do the minimum amount of work possible. Gravity works. So flip to the back now.
Is that like a casualty thing that you do or something?
That's just a sketch phrase.
When I drop things.
Yeah, this should
It's a
be
gravity check. If gravity didn't work, we'd all be really screwed.
Because that's what my brother's fiance does all the time when she teaches in the class. Whenever they drop something,
Maybe she stole it from me, who knows?
you know, she doesn't want her students to call her clumsy. She just says gravity works.
Wait, do they make those rooms that have like no gravity in them, so you can like float like in space? Like a space simulator?
They do different things to do that. The most common one for training uses parabolic arcs. So if you fly a plane and you go up really hard, you feel it, right? If you've ever been in a plane, when you take off, you kind of get pushed into the seat. So then if they turn and they come down really dramatically, the plane is falling. They can fly fast enough to make the plane fall at the same rate that gravity is pulling you down. So if you're falling at the same rate that gravity's pulling you down, you're not really falling, you're floating. So, no, because gravity's still pulling you down then. So, when you're in the plane, whatever, and you're falling at the same speed as gravity, the plane and you are falling at the same speed of gravity, you don't feel gravity. Right now we feel gravity, we're on the ground. But you would literally be able to do this and float to the other end of the plane. Or what? It's what, if you look up OK Go's one music video if you want to see what I'm talking about. If they tell me that the area divided by circumference is 11, well, we actually know that area divided by circumference is half your radius. So that tells me that 11, you should be writing this down, is really my radius divided by 2, or that 11 is half of my radius. Which means to calculate my radius, well, what do I need to do? Anthony, what do you think? If I want to calculate my radius when I know what half the radius is. Ooh, yeah, take the value that you know is your half, multiply by 2. So that then gives me that my radius is 22. We do not have units, so we would just label that as units. That then would also tell me that my diameter is twice that, or 44. That my circumference would then be 44 pi, and that my area would be 22 squared times pi. I can calculate all of that from just a little ratio that they gave me. A comparison of area to circumference. Let me literally calculate every single thing about my circle. So this is saying that the area of the circle is 11 times the circumference. So if you think about this using actual units, like if this was feet, if we're talking 22 feet across, that's probably about as big as my room. That's probably about 22 feet. I should really measure so I know these things. But that distance, then the distance around it, that's 44 pi. The distance in it, this would be really big. 22 squared would be over 400 times pi. 484 pi. So yeah, that would be a very large amount of square feet in here. But that'd be like if you had a round room and you wanted to carpet it. What's the area of the round room?
Did you figure out my riddle?
No, I forgot all the details though. I need it written down. I can't, or you need to email it to me.
Get you to write down.
If we wanted to build this formula, if I compare area with circumference, so area is pi times radius squared, right? And circumference, we're just going to play with numbers for a second, is pi times 2 times radius, if we use those formulas. Then couldn't I, in each of those, isolate the radius? Could we isolate the radius there? Yes. Because this, I could really rewrite. A couple of you guys have told me multiple times, I could rewrite this as pi times radius times radius. And then if I do that and set that equal to a, because I'm still equal to a, to get radius by itself, I could divide by these so they can cancel. And I could say that the radius is the area divided by pi times the radius. That's weird.
Oh my goodness.
We're just playing with numbers. We're just seeing what happens. Yeah, that's really messy. I could also down here, don't take up all your space by the way. I could down here isolate radius by again getting rid of the pi and the 2. So that would become circumference divided by 2 pi, which actually if you know the circumference, that's one way that you can get to your radius. That's a good formula. Now here, this is kind of worthless because you have to know your radius to find your radius. So this is kind of a dumb formula. This is true, but it's kind of dumb because we use the radius twice. Why would you look for radius if you know radius? Doesn't make sense.
what if I actually just do this? What if I just put them over top of each other? If I put area over top of circumference, so let's stop all this nonsense over here. I mean, it's fun to look at and play with. But if I just do this, then what I really have, if I clean this up, is pi times radius over pi times radius times 2. That's just area divided by circumference. Melee, can you see anything that is the same on top and bottom that could cancel with each other? Ooh, the radius can cancel with itself. Anything else? The pi can cancel with itself. Those both become 1. And when this simplifies out, I get r divided by 2, or half of r. So, algebraically, when we check our hypothesis, because when we built that formula just from some examples, that was really a hypothesis. It worked for those circles. We don't know it works for all of them till now. This proves that this will always be true. Questions on this? So on your homework, when it gives you the area divided by circumference is something, that something that it gives you is just half your radius. So if they give you that, the area, so check out this right down here. The area divided by circumference is 7. So, Kylie, what would you do if you were given that area divided by circumference was 7? Or what do you like immediately think or know, or what can you figure out? Yeah, that's half of your radius. So what would your radius actually be there? No, that 7 is, yeah, you got to go the other way. We need to double. So when we're given that ratio, we double to find the radius. But then it says find the circumference, and we know to find circumference, we'd really rather have diameter. So if my radius is 14, that tells me my diameter is, anybody? 28, because we double again. And then I can say my circumference is the 28 times pi, because it says to leave my answer in terms of pi. Well, on Pi Day, we will have that competition. I think the current Phoenix record for pi memorization was 68 on Pi Day, like on the Pi Day contest. Yeah, I niched it a bunch. But... Alright, that's all we got for today. Please try your homework. Our Chapter 10 Masteries tomorrow. If you are missing a bunch of homeworks, you will not be taking the Masteries.